Let me show you how to read an oscilloscope and use an oscilloscope. This is the power button. This will change the intensity of the trace. We can focus it with this, right? Okay, and then we can actually illuminate the scale. I think this illumination might be broken on this one. But anyway, now notice we actually have two channels here. I'm only using channel 1, okay? So, and I'll have this set up, right? So it's going to trigger on channel 1. And basically what this does, the way an oscilloscope works is that the vertical axis here is voltage, the horizontal axis is time, okay? And what it does is it picks a particular time to trigger, and that's when it draws a trace across the screen. So really what it's doing is drawing the same picture over and over many, many times, okay? And it triggers at a particular level. So you can change the level there, see the left side? That's where it begins. We can also change the slope, okay? So now it's a down slope. I can trigger, so it starts when it's going down, starts when it's going up. It's a bit like the RC circuits lab, right? We said trigger when it's decreasing across 4.8 volts, right? Okay, but this is triggering increasing across whatever this voltage is there, okay? Now when you first sit down at this thing, what you want to do is you want to ground it, and that just tells you where 0 is. Notice that 0 is not reading 0 on there, and this is common, okay? So what you're going to do is you're just going to make it read 0. So click that to ground, make this read 0, and it should go straight across. I feel like I need to adjust this rotation because it's not really straight across. It's close to straight across, right? Okay? But anyway, once you've got it on 0, now we can read this, okay? When you read an oscilloscope, you read these divisions. This is, if you look at this, this is 1, 2 divisions up, right? Now notice that this thing is adjusted to 5 volts per division. So this is going to be 5, 10, and maybe just a little more up, right? So maybe that's 11 volts or something like that from 0 to the top of that. That's how you do this, right? Okay. And then if we look sideways, side to side, right, you can see, and it helps to do this. You can move this thing back and forth, right? You can move it up and down. And one of the things you can do is just sort of center it, right? It looks symmetrical about 0, right? But when you're measuring the time, I always like to put this thing right on maybe the center, or you can just pick any division like that line there, put it right on there. And now we can count squares across. 1, 2, 3, 4. It's exactly 1, 2, 3, 4 squares across. Well, how much time is that? This thing is pointing to 0.5 milliseconds per division. So it's going to be 1, 2, 3, 4 times 0.5 milliseconds per division, okay? And that'll give you the time. Remember, a millisecond's times 10 to the minus third seconds. Now you can change this graph, right? I can make the time scale bigger. So now it's 1 millisecond per division. Now it's 2 milliseconds per division. And then you can see if you go here, this is 50 milliseconds. Here's this is 2/10 of a second per division. 1001, 1000, 1001, 1002. It takes 2 seconds to go across, right? You can see what it's doing, right? It's just scanning across. So you can just pick whatever horizontal axis you want. And then this is our vertical axis. Oops, that's, here we go. Here we go. And so it's basically making a graph of voltage versus time. And I can make, this is attached to a function generator, so I can make a different function. This is a sawtooth function, right? Named after the Sawtooth Range in Wyoming. I don't know where it is. All right, this is a square wave. And you can't really see, but there's actually little traces that go up and down. I don't know if we can see it. I can't really see it. So, you can see whatever function it is. And typically it's more complicated than one of these 3 functions. Let's go back to our sine wave like that. Okay. Here, I'll turn this down. So you can, and typically you just sort of want to make it so it fits on the page. So here's our vertical axis changing. Here's our horizontal axis changing, right? All right, that's sort of what you need to know.